Hello. In this video, we will this will be in this video we'll take a function and turn it into an infinite series. This is also called power series and function. So this is calculus 2, power series and function. So the power series gets its roots from the geometric series. And then the geometric series is basically a special case of a power series where x is a variable and a naught, a1, a2, and 3 an are constant. So here's an example of a geometric series. Recall that the sum of an infinite geometric series is the formula is AR summation of n equals 0 to infinity of AR raised to the n is A over 1 minus R. You've probably seen this in pre-calculus. If they ever ask you to find the sum of infinite geometric series, you would use this formula. Now, if we let a equals 1 and r equals x, provided absolute value of x is less than 1, then the summation from n equals 0 to infinity of 1x raised to the n is 1 over 1 minus x. So the function f of x equals 1 over 1 minus x can be represented with the power series of n equals 0 to infinity of x raised to the n. So basic form for a power series is 1 over 1 minus x equals 1 plus x squared is equal to the summation of n equals 0 to infinity of x raised to the n. The goal is to manipulate other functions to look like this. So let's do an example. Example 1 says find the power series representation for the function f of x equals 1 over 1 plus x. So yeah, we got to find the power series of this function. So if you recall, remember, one over one minus x is equal to the summation of n equals 0 to infinity of x raised to the n. We don't have that, but we almost have it, right? The only difference is we have a plus. So we can actually rewrite it or manipulate it as this. One minus the negative x, right? We haven't changed the problem. We just one minus negative x is the same thing as one plus x. And we can say that equals to the summation of n equals 0 to infinity of negative x raised to the n. Right? Right? We said that if you have 1 over 1 minus x is the same thing as x raised to the n, but we have this extra minus, so that's why I put an extra minus here. Okay, so you just need to know this rule. This rule is important, so write this in your notes. We can also rewrite this if you want. This minus is like invisible negative 1. We can rewrite this as a summation of n equals 0, infinity of negative 1 times x raised to the n. And then this could be your final answer. Since we're raising everything to n, uh, when you raise power, you multiply the exponents. So this can also be expressed as, your final answer can be expressed as the summation n equals 0 to infinity of negative 1 raised to the n times xn. Okay, so that's your final answer. let's move on. Okay, let's look for example. Example two says, find the power series representation for the function of f of x equals 1 over 2 minus x. So what we could do is, what could we do? Let's get rid of this. Do you see this too? Let's try to make that into a 1 because technically want to make it, you technically want to make it look like this, 1 over 1 minus x, right? So how do we get rid of this 2? You're going to have to divide everything by 2, right? This would be 1 over 2, 2 over 2, minus x over 2. Okay, so you have 1/2, and then 2 over 2 is 1 minus x over 2. So what could we do? Oh, what we could do is, because we wanted a 1 on the top, what we could do is factor out this constant. So we can say the x equals to 1/2. So 2. And that gives you the summation of AR raised to the n. Then you can say final answer could be expressed, or one of your final answer could be expressed as so the summation of n equals 0 to infinity of 1/2 times x over 2. So yeah, so it's x over 2 because we had, if you recall, 1 over 1 minus x is equal to the summation of n equals 0 to infinity of xn, right? What we have is we have this 1/2, so I put the 1/2 in front. And then uh, the only difference is there's like an extra, this should just be an x, but if you could think of it as like a 1/2 times x. So that is why, yeah, that is why I put in x over n raised to the n. Uh, Another way you can also express this is one way, this could be one of your answers. If you want to go more detailed or more deep, you can rewrite this as the summation of n equals 0, infinity. And then you can rewrite this right here can also be expressed as x raised to the n over 2 times 1 times 2 to the n, which equals to the summation of n equals 0 to infinity xn over 2 raised to the 1 n. Now, you can also, believe it or not, you can also rewrite this as a negative power. So you can also say the summation from n to 0 to infinity of 2 to the negative. You can rewrite this as a negative power because it's in the bottom, right? So -1 minus n raised to the xn. Okay, let's move on to example 3. So example 3 says, find the power series representation for the function f of x equals 5 over 1 plus x squared. So we really want to make it, you have to write this rule more than once, that's fine. 1 over 1 minus x equals to the summation of n equals 0 to infinity of xn. Okay. So let's see, maybe we can make this 5 into a 1, and maybe somehow we can make this plus to a negative. That's easy. But what about this x squared? Well, let's start with the 5. Let's make this 5 to 1 by factoring out that 5. So you can rewrite this as f of x equals 5 times 1 over 1 plus x squared, right? And then let's make this positive to a negative. So it's going to be 1 minus negative x squared. And what else could we say? Uh, so this can also, if you simplify this even more. So this could be the summation of n equals 0 to infinity 5 times negative x squared raised to n. And then this is like an invisible -1, so you can say -1 times x squared raised to the n. And your final answer can be expressed as the summation from n equals 0 to infinity 5 times -1 raised to the n times x to the, so remember when you raise, you multiply the exponent, so this would be 2n. So this is your final answer. Okay, let's move on to example 4. So example 4 says find the power series of 1 over x cubed plus 4. So if you write out your rules, so you want to make it look like this. And what can we do? Maybe if you want to see how the x is on the left, maybe we could put that x to the right, so we can rewrite this as 1 over 4 plus x cubed. I don't know if that makes it easier for you, but it does for me. And then somehow I want this 4 into a 1, so how do I do that? Yes, divide everything by 4. It's going to be 1 over 4. 4 over 4 is 1. You get 1. And then somehow we have this 1 4. So I'm going to make that into 1 by factoring it out. So that's going to be a 1 4. 1 over 1 plus, let's keep it. Somehow I want to make this, now I want to make this plus 2 negative. So it can be f of x equals 1 4. Yeah, so we get 1 minus equal 4. We get the summation between of x cubed raised to the n. And then this could be written, since we're raising it, everything to the end, so your final answer could be 1 4. It's negative 1 to 1 x cubed raised to the n. And then 3 raised to the n is 3n over, and then 4 to be expressed as 1 plus n. And I guess this could be your final answer. Okay, let's move on to example 5. Find the power series representation for the function uh, x over 1 minus x. So, this is just, I wrote this riddle. I mean, this is what we need to use. But our function is f of x equals x over 1 minus x. So what shall I do? Maybe I could factor out this x, and that'll give us a 1 because we want a 1 on the top, right? So maybe that's what I should do first. So I'm going to factor out an x. That's going to be x times 1 over 1 minus x. And then, yes, now we have 1 over 1 minus x is xn, but we have an extra x, so we can say this, or you can also say x bracket destination. You can also, your final answer can also be expressed as this. Okay, so that is your final answer. So let's move on to example 6. Okay, example 6 says find the power series representation for the function f of x equals 2x squared over 1 plus x cubed. And I wrote down this to help us to solve this. So there's a lot of going on. Let's start with the 1. Let's the numerator 1. Let's make this into 1. So what we could do is factor out a 2x squared. And then let's make this positive to a negative. So let's say 2x squared, not 2x. You get this. Final answer could be expressed as the summation from n equals 0 to infinity, 2x squared. And then uh, let's make, let's make this, since the x cubed on the bottom, it's going to be negative x to the third. Oh, no, because we have an extra minus here, so this is why there's a minus x cubed raised to the n. Or you can also say this is also the same thing as a summation of 0 to infinity, and this is the same thing as 2 times x squared times negative 1 raised to the n times x raised to the 3n. That gives you summation n equals 0 to infinity of 2 times negative 1 raised to the n of x to the 3n plus 2. Okay, let's move on to example 7. Okay, so example 7 says find the power series representation for the function, and then I use this definition to help us. So we have f of x equals 3x squared over 5 minus 2 cube root of x. Lots of going on. Let's start with the 1. Let's make this 3x squared into 1 by factoring out that 3x squared, right? I'm going to factor 3x squared, and you get 1 over 2 cube root. Now what to do? Let's make this 5 into a 1 by dividing everything by 5. Five divided by 5 is 1. Now, this is now 1/5 here. I still want that 1/5 into a 1, so maybe we can factor out that 1/5 out, right? So I'm factoring in 3x squared and also 1/5 to make the numerator 1. That gives you the summation A is the end. So our answer can be expressed as this. Three x squared tells 1/5, that is 3x squared with 5. Um, 2/5 cube root of x. And then that could be expressed as the summation n equals 0 to the fifth squared is 2/5 third raised to the n. We get the summation we get this summation of 3/5 times x squared times 2/5 raised to the n times x to the 1/3 n, and that gives you the summation n equals 0 to infinity 3/5 is 2/5 and x to the 2 plus 1/3 n. My final answer. Oops. So this could be your final answer right here. Let's move on to example 8. Okay. All right. Example 8 says find the power series yeah, example 8 says find the power series representation for the function if the denominator is not a binomial or if the numerator is not a binomial or wait. So let me reread the question. It says find the power series representation for the function if the denominator is not a binomial or the numerator is not a monomial. So monomial means one term, binomial means two terms. Then we must use the partial fraction. And so if we have, this is what we have, f of x equals 3 over x squared plus x minus 2. So the numerator is fine. It is definitely a monomial, right? Meaning it's one term. That's perfectly fine. But the denominator is not a binomial, it's a trinomial, right? So we got a problem. It's not a but the bottom is not a binomial, it's a trinomial. So to convert this trinomial into a binomial, you can complete the square or partial fraction decomposition. So I'm just going to use partial fraction decomposition. Make it into a binomial. Okay, so on the bottom, maybe if we factor out the bottom, you get f of x equals 3 over x plus 2 times x minus 1. And so wait, now you have, so how, we're gonna set it up like this. Okay, uh, so it would be a over x plus 2. And why do I put an a? Because if you take the derivative of x plus 2, you're left with a constant, right? And then the second would be b over x minus 1. Why did I put it b? Because if you look at the second term, x minus 1, what's the derivative of that? 1, which is a constant. So that's why I put b. Okay. Now, what we're going to do is solve for a and b, but first we must get rid of the fraction by multiplying all sides by the LCD, right? So what is my LCD? Yes, it is x plus 2 and x minus 1. Okay, so over here, what's x plus 2 times x minus 1? The 3 cancels. Over here, the x plus 2 cancels, so you're left with a times x minus 1. Plus, over here, what cancels? The x minus 1 cancels, so you're left with b times x plus 2. Okay, and now what we're going to do is, what if you let x equals negative 2? Okay, so you get 3 equals a, and then replace x with negative 2, so that's negative 2 minus 1, and then this is negative 2 plus 2. Negative 2 minus 1 is negative 3a. Negative 2 plus 2 cancels, so you're just left with 0. And then if you try to solve for a, you're going to divide this by negative 3, divide this by negative 3. You get a equals negative 1. Okay, now let's find b. So to find b, if you let x equals positive 1, you're going to get this 3 equals a, and then it would be 1 minus 1 plus b, and then this would be 1 plus 2. So this cancels. And then you're left with 3 equals 3b. Solve for b, divide this by 3, you get b equals 1. Okay, so now our function is of x equals -1 over x plus 2 plus 1 over x minus 1. Okay. And then if we use our rule, now what can we do? Oh, so what we have is two things. This is fine, and this is fine. So somehow we have to make it into a one, or for each of these, we have to make it 1 over 1 minus x. So if you look at here, this is I got to make this into a positive one. So what I'll do is maybe factor out a -1. Yeah, I'll factor out a -1. And then, yeah, 2 plus x. So what I'll do is I'll put the x on the right. So I'll put the 2 on the left. So it's 2 plus x. And somehow I want to make this 2 into a 1. So I'm going to have to divide everything by 2. This is going to be 1/2 over 2 over 2 plus x over 2. And now I want to make this 1/2 into a positive 1. So it's going to be -1 times 1/2. And you have 1 over 1 plus x over 2. Okay. And then -1 times 1/2, that could be simplified as -1/2. Now I have 1 over, and then I want to make this positive into a negative. So it's going to be 1 minus -x over 2. Now let's do the other one, the 1 over -1 plus, right? Because we have two things. I'm referring to this one right here. Okay. So yeah, let's do the 1 over x minus 1. So that, if you want to, somehow we have to do 1 minus 1x. And somehow we have to make it look like that, if possible. And that equals to the summation equals 0, infinity, xn. Okay, so the first thing I would realize is let's put this x to the right and move the cons to the left. So we'll just rearrange the bottom. We're not doing anything directly, just rearranging it. That doesn't change our problem, right? So it's -1 plus x. And now what I would do is make this negative into a positive 1. And to do so, I'm going to have to divide everything by -1. So now 1 divided by negative 1 is just negative 1. I still want that to be a positive. Negative 1 over negative 1 is positive. X divided by negative 1 is negative x. So the bottom is really good. That's what we want. I want this negative 1 to be a positive, so that's why I have to factor out a negative 1. Okay, so what do we have now? So in the first term, on the first, yeah, the first term we had negative 1/2 times 1 over 1 minus negative x over 2. And then on the second term, the one we just did, you have a negative 1 times 1 over 1 minus x. Yeah. Let's do the summation thing. So over here, what would be the summation? It would be expressed as this. Then over here, this could be expressed as a summation as this. And then let's just clean this up more. So over here, this simplifies as negative 1, 2, negative 1. This is like a negative 1x, negative 1 raised to the n times x to the n over 2n. Oops. And over here is will be expressed as summation of n equals 0 to infinity, negative 1 xn. And get summation of n equals 0, infinity, negative 1 raised to the n plus 1 xn. There 2 plus 2 raised to the 1 plus n plus negative 1 to 1 xn. So you can write this as a single summation. It would be the summation from n equals 0 to infinity, negative 1 raised to the n plus 1 over 2 to the 1 plus n plus negative 1 times xn. Okay. Okay, let's move on to example 1. Okay, example 9 says find the power series representation for the function if the denominator is not a binomial or if the numerator is not a monomial, we must use partial fractions. So what we have is, in example 9, we have 3x minus 1 over x squared minus 1. So we have two problems, right? And we want to make it into 1 over 1 minus x. So the numerator is not a monomial. I believe it's a binomial. And then the denominator is okay. It's definitely a binomial, right? It's okay to have a binomial in the denominator. So we got to somehow make this numerator into a monomial by using partial fraction. So let's do that. So to set up your partial fraction, it would be expressed as 3x minus 1 over, and then x squared minus 1 could be factored out as, because you want it in the most factor form. It's a perfect square, so it'd be factored out as x minus 1 times x plus 1. And then it's going to be a over x minus 1. Why do I put an a on the top? So you get people always would ask, why do I put an one? Why do I put an a or should I put an ax? Well, you just what I do is take the derivative of this of the first term x minus 1. What's the derivative of that? 1, which is a constant. So a is a constant. If it was like x squared minus 1, it would be 2x, and then you would put in ax, right? Okay. And then the second would be b over x plus 1, because you take the derivative of x plus 1, which is 1, which is a constant. Okay. Now let's get rid of, we got to solve for a and b by, let's see, by multiplying both sides by the LCD, which is x minus 1 times x plus 1 on both sides, right? So over here, what cancels the denominators? So you're left with 3x minus 1. Ah. Over here, the x minus 1 cancels, so you're left with a times x plus 1. Over here, the x plus 1 cancels, so you're left with b times x minus 1. Okay, now what we'll do is maybe we should FOIL. If we FOIL it out. Yeah, I think, yeah, let's FOIL that a out instead of replacing x with -1. I mean, you could replace x with -1. I think that would work too. Or would it? No, it wouldn't. So what we would do is just, yeah, FOIL out the a and b. So a times x is ax. A times 1 is regular a. B times x is bx. And then on the left, it's 3x minus 1. Now what I would do is like collect like terms, I believe. So let's collect anything with x's. So we have an ax plus bx. And then let's collect everything without x's. So we have an a minus b. So this is 3x minus 1. Let's see here. Ax plus bx, you could factor out an x. So that's a plus b times x. And then this is just a minus b. And then this is 3x minus 1. So now what I would do is like, you see this a plus bx, that goes with the 3x, right? But you can like ignore the x's. So this would be, you have like a system equation, 3 equals a plus b. And then this -1 goes with the a minus b. So it would be -1 equals a minus b. Okay, and then eventually what I'll do next is get rid of the b's. The b's cancel, so you're left with 2a, and then 3 minus 1 is 2. Divide this by 2, you get a equals 1. And then over here, we could solve, now you can substitute it back into either equation. I'll just use the first one. So it's going to be 3 equals a is 1, so it's just 1 plus b. And then solve for b, so subtract 1, get b equals 2. Okay, so the numerator, uh, so now your function could be expressed as f of x is, so a is 1, so it's going to be 1 over x minus 1. And b is 2, so it's 2 over x plus 1. Okay, let's see, so somehow we have to make it look like this. 1 minus x equals the summation n equals 0 to infinity of xn. Okay. This one's really good. It's exactly what we want. Um, that is, yeah, that's good. Actually, no, it's not good. It's not. It almost looks like it. It's not quite, right? It's actually 1 over, and then this is negative 1 plus x, right? So yeah, we got to do some manipulation. We got to make it look like this. So what we have to do is make this negative 1 into a positive 1 by dividing everything by negative 1. Okay, so I get negative 1 over negative 1 is positive 1. X divided by negative 1 is negative x. Now we still have one more problem. We got to make this negative 1 into a positive. So to do so, I'm going to factor out that negative 1, right? So I'm going to factor out negative 1, and you get 1 over 1 minus x. Okay. So this negative 1 is your a. This is like your n. Now let's do the other term. So the other term is 2 over 1 plus x. And we somehow have to make it look like 1 over 1 minus x. So first thing should I do is maybe factor out this 2. So it would be 2 over 1 over 1 plus x. And I want this positive x into a negative, so we can rewrite this as 2 times 1 over 1 minus negative x. Okay, so our two summation. Okay, so the first summation for this one would be expressed as the summation of n equals 0 to infinity of negative 1 raised to the times by x to the n plus the summation of n equals 0 to infinity of 2 times negative x raised to the n. And then what you could do is break it down more. So this is the same thing as the summation n equals 0 to infinity of negative 1 times that xn let's just make it into one single summation. Or actually, no. And then this right here could be expressed as the summation of n equals 0 to infinity of 2 times -1 raised to the n times xn. Now we can simplify it into one single summation. So it's going to be the summation of n equals 0 to infinity of -1 times xn plus 2 times -1 raised to the n times xn. And then your final answer can be expressed as this. Okay, so this is your final answer. Okay, so what happens is sometimes we can't change our function to our base power series from 1 over 1x easily. So we'll have to use differentiation or integration, right? So what we did previously is we kind of manipulated to make it look like 1 over 1 minus x. And if the numerator was not a monomial and if the denominator was not a binomial, you had to use partial fractions, right? Sometimes it won't be that easy, so then you would have to use differentiation or integration. Right here. Yeah, so this is what I just said. Uh, yeah. So if you can't easily put it in the power series 1 over 1 minus x, you will have to use differentiation or integration. These are just rules. So if you recall, if you have C naught plus C1 times x minus a plus C2 x minus a plus C3 x minus a cubed, you can take the derivative. The derivative C naught is a constant, so the derivative of the constant is 0. Uh, over here, what's the derivative of C1 times x minus a? Uh, yeah, it's just C1. Because I think they did was use the power rule. So 1 times C1 is C, and then x minus a times the derivative. So that's how you get C1. C2, you just used the power rule and so to this one right here, the derivative of this is they use the power rule and the chain rule to get to this 2C2 x minus a. Okay, and then the third one, same idea. They use the power rule. So 3 times C3 is 3C cubed, and then it's x minus a, and then this stays the same, and then power rule, so old power minus 1, so 3 minus 1 is 2, times the derivative of the inside, just 1. So that's how they got this. Okay. So I think this is a very important rule on the summation of ARN of a times r raised to the n equals to the summation of n equals 0 to infinity of 6cxn. Example 10 says find the power series. So let's do an example. Find the power series representation for the function using differentiation of 1 over 1 minus x squared and somehow we have to make it look like this. So the numerator is fine, it's a monomial, but the bottom is not fine. It has a power 2, right? So what we'll do is use what we know. 1 over 1 minus, let's use the rule, 1 over 1 minus x. What we could do is rewrite that as a negative power, right? Because we have powers, right? So I'm going to rewrite 1 over 1 minus x as 1 minus x to the negative 1. And now the summation rule is still the same. Okay, then what I would do is take the derivative of 1 minus x to the negative 1. And then you got to, the rule states if you take the derivative one side, you must do it on the other side, right? So how do you take the derivative of 1 minus x to the negative 1? Yes, you must use the power rule and the chain rule. So start with the power rule. This has an invisible 1, so what's 1 times negative 1 is negative 1. Leave the inner parentheses alone. And then it's old power minus 1, so still power rule. What's negative 1 minus 1? Negative 2. Then you apply the chain rule, so basically it's just the derivative of the parentheses. So the derivative of 1 is 0, the derivative of negative x is negative 1. And when you clean this up, so negative 1 times negative 1 is positive 1. And then let's rewrite 1 minus x to the negative 2 as a positive power. So you put 1 minus x squared on the bottom. And then how do you take the derivative of xn? Yes, power rule. So your summation is going to be n equals 0 to infinity of nx. So power rule. This has a coefficient 1, so 1 times n is n. Leave x alone, and then it's whole power minus 1. So how does this help? This is not our answer. What we did was we just rewrote 1 over 1 minus x into a negative power. But if you compare it, see what we had was let's compare. We had f of x equals to 1 over 1 minus x to the square, right? And yes, wait, actually that is our answer. So this is our answer. Because why is that our answer? Because we got to here, right? When we took the derivative, we got 1 over 1 minus x squared, which is this, right? So that's how I know that is our answer. That's pretty cool, right? Okay. Now we can do the same concept with the other problem. So let's move on to question 11. Example 11 says, find the power series representation for the function using differentiation. And we have f of x equals x squared over 1 minus 2x squared. And we want to compare it with this. So yeah, this was given. So yeah, this is so what we'll do is let's start right here. I want to make this x squared into a 1. So what I will do is factor out that x squared. And I get 1 over 1 minus 2x. And x squared is your a, negative 2x is your r. So we get the summation of n equals 0 to infinity equals to x squared times 2x raised to the n. Okay, now let's do this part right here. Let's see, let's make this x squared into a 1. So what we'll do is we write it as x squared times 1 over 1 minus 2x squared. And then the base form is this. So this is why we did this, because we're going to relate it. This is our base form, right? So base form is this. 1 over 1 minus 2x, which is this, is equal to the summation of n equals 0 to infinity of 2x raised to the n. So what I will do next is from the side here, 1 over 1 minus 2x, let's rewrite that as a negative power. That could be expressed as 1 minus 2x to the negative 1 equals to the summation of n equals 0 to infinity of 2x raised to n. Then what I would do is take the derivative of both sides. So yes, take the derivative of both sides. So how do you take the derivative of parentheses 1 minus 2x to the negative 1? You use power rule and chain rule. So let's start with the power rule. This has an invisible 1. So 1 times negative 1 is negative 1. Leave the inner parentheses alone. And then it's old power minus 1. So negative 1 minus 1 is negative 2. And then times it by the derivative of the inner parentheses. So the derivative of 1 is 0. The derivative of negative 2x is negative 2. So when you do clean this up, negative 1 times negative 2 is positive 2. And then 1 minus 2x to the negative 2, that can be expressed as a positive power as 1 minus 2x squared. And then over here, how do you take the derivative of 2x? Parentheses 2x raised to the n, yes, you use the power rule. So this would be n times 2x raised to the n minus 1. And then don't forget you've got to use chain rule. So the derivative of the inner parentheses, what's the derivative of 2x too? Okay, so let's clean this up a bit. So this simplifies as 2 over 1 minus 2x squared equals the summation of n equals 1 to infinity. If you want 2 as a constant, so you can put that in front of summation. And then now you're left with n times 2x raised to the n minus 1. Okay. What I do next is let's look at the left side. So we still want this right here to somehow make it into 1 over 1 over 1 minus x, right? That's our goal. So what can we do? Well, we can get rid of that 2 on top right here. So to get rid of that 2, you're going to factor out a 2. So it's 2 times 1 over 1 minus 2x squared equals to the summation of n equals 1 to infinity of 2. And then you have 2 times 2x to n minus 1. Let's see what happens. See, do you see these two? You could divide each thing by 2, and then that will get rid of the 2. So now you're left with one over parentheses 1 minus 2x squared equals to the summation of infinity n times 2x which is n minus 1. You get f of x equals to x squared minus the summation of infinity 2x is n minus 1. And then this could be broken down as summation of n equals 1 to infinity of x squared times 2. So I'm just breaking it down, expanding it. Parentheses 2x raised to the n minus 1, that's the same thing as 2 to the n minus 1. And to the n minus 1. Right? Your final answer will be expressed as the summation of n equals 1 to infinity of n times 2 n minus 1 x to the n plus 1. Okay. Let's move on to example 12. So example 12 says, find the power series representation for the function using the differentiation. So I didn't write the question. The question is f of x equals 1 over parentheses 1 plus x to the third. And then they say to use this base form to help you out. Okay, so this should help. Okay, now what I'll do is in example 12, yeah, we got a power 3, so that's what makes it a little bit difficult. So what would I do? Maybe let's make this plus x into a negative. So you can rewrite this as f of x equals to 1 over 1 minus the negative x to the third, right? And somehow we have to use a space form, so we have 1 over 1 minus x equals to the summation of n equals 0 to infinity of xn. Now, let's make 1 over 1 minus x as a negative power, so it's going to be 1 minus x to the negative 1 equals to the summation of 0 to infinity. Now what I would do is take the derivative of both sides, right? So how do we take the derivative of 1 minus x to the negative 1? We use power rule and chain rule. We start with the power rule. So negative 1 times 1 is negative 1. And then you have 1 minus x, and then full power minus 1, so negative 2. And then apply the chain rule, so the derivative of the inner parentheses. So derivative 1 is 0, the derivative of negative x is negative 1. Over here, this is easy. How do you take the derivative of this? You use power rule. Power rule. So this has a power coefficient of 1, so 1 times n is n x to the n minus 1. Let's clean this up. Negative 1 times negative 1 is positive 1, and then let's make 1 minus x to the negative 2 as a positive power. So now what we have is negative 2 and 1 minus the negative 3 times negative 1. And that equals to the summation of n equals 2 to infinity of n times n minus 1 times x n minus 2. I'm doing the f of x. Yeah, the f of x over 1 plus x cubed, right? So what I would do next is, so the simple, over here, if you clean this up, negative 2 times negative 1 is positive 2. Minus 2. And then on the right, it's going to be simplified as the summation of n equals 2, infinity, n times n minus 1, x raised to the n minus 2. Let's get rid of this 2 because we want it to make it into 1. So to get rid of this 2, you're going to multiply both sides by 1/2, right? So this now becomes a 1. and then this is 1 minus x, 1 minus x raised to the third, and then this is going to be 1/2 times the summation of n equals 2 to infinity of n times n minus 1 of x raised to n minus 2. This x should be positive, so let's make that into a positive. So what you can do is do an extra minus. So it's going to be 1 over 1 minus negative x to the third. And this is going to be 1/2 the summation of n equals 2 infinity Okay, so now this becomes a positive, so it's going to be 1 over 1 plus x to the third equals to 1/2 of the summation n equals 2 to infinity n times n minus 1 negative 1 raised to the n minus 2 times x to the n minus 2. So your final answer is going to be the summation of n equals 2 to infinity 1/2 times 2 times n minus 1 times negative 1 raised to the n minus 2 times x to the n minus 2. Okay, so that's your final answer. Okay. Uh, okay, but what if, okay, so if our n was 2, what happens if n equals 0, right? So what if n equals 0? So if you just need to know this rule, the summation of I equals p of n, that's I, is going to equal to the summation of I equals p plus r of n plus r of x raised to the 1 I minus r, right? And this is going to give you the summation of I equals p minus r of n minus r of x to the I plus r. So the summation is n equals 2 of infinity of 1/2 times n minus 1 minus negative 1 raised to the n minus 2 of x to the n minus 2. So let's say if your n was 0, you get summation n equals 0 to infinity 1/2 times n times n minus 1 times negative 1 raised to the n minus 2. That's n. Okay. So another rule we need to know, just like differentiation, we can also integrate the terms of the series to get an integral of the series if it doesn't get it. So if we can't make it into our base of 1 over 1 minus x, And we've tried partial fractions. We've tried differentiation. You can also integrate it. Okay, so just like what I just said, just like differentiation, we can integrate the terms of series to get the integral of the series itself. So the integration of f of x d of x is the integration of the summation of n equals 0 to infinity of Cn times x minus a raised to the n dx. And then f of x, big f of x plus c equals the summation of n equals 0 to infinity of the integral of Cn x minus a n times d of x. If you need to break this all down, it's fine. But I'll do an example. And then big f of x plus c equals the integral from n equals 0 to infinity of Cn times x plus a of n plus 1 over n plus 1 c. The constant of integration, let x equals. So yeah, for constant of integration, let x equals 0 to find c after the integration. So if you recap 1 over 1 minus x, 1 over 1 minus x, and we took the derivative. So let's try example 13. Example 13 says, find the power series representation for the function using f of x equals ln of 1 plus x. So definitely I'm not in the form. Not form. 1 over 1 minus x, right? So what we could do is try to take the derivative of ln of x. So let's try to take the derivative of ln of x. The derivative of ln of x is 1 over x. So what is the derivative of 1 plus x? The derivative ln of 1 plus x is what we have. It's pretty simple. It's just 1 over the parentheses times the derivative of the parentheses. So derivative 1 is 0, the derivative of x is 1. So it's just this. So yeah, so we could say f prime of x is equal to d over dx of ln of 1 plus x equals 1 over 1 plus x. We know that 1 over 1 plus x we can rewrite that positive x into 1 over 1 minus a negative x. And that gives you the summation of n equals 0 to infinity of negative x raised to the n. We get 1 over negative x equals the summation n equals 0 to infinity of negative 1 raised to the n times xn. So what we would do next is take the integral of 1 over 1 plus x. So the integral of 1 over 1 plus x of dx is equal, now you have to take the integral both sides, right? So the integral of the summation of n equals 0 to infinity of -1 n times xn dx. And what is the integral of 1 over 1 plus x? You could do u substitution. You could say u equals 1 plus x, and then the derivative of that is 1. So it's really saying the integral of 1 over u, which is ln of the absolute value of your u, which we said was 1 plus x, equals. How do you take the integral of this? It's just basically its power, whole power plus 1 divided by that power. So the integral of this is going to be the summation of n equals 0 to infinity of -1 raised to the n times x to the n plus 1 over n plus 1 plus c. Okay, now the next step is now we solve for c by letting x equal 0. So let's do that. So it's going to be ln of 1 plus 0 equals the summation n equals 0 to infinity of -1 raised to the n. Remember, replace x with 0, so it's 0 to the n plus 1 over n plus 1. Let's see. We get ln at 1 plus 0 is wait. 1 plus 0 is 1, and then add the ln of 1 is 0. So 0 equals to c. Because this all becomes 0, because 0 times anything is 0, right? So final answer will be, oops. Yeah, so your final answer is going to be f of x equals to ln of 1 plus x is equal to the summation of 0 to infinity of -1 is the n and x to the n plus 1 all over n plus 1. Okay, let's do 2 more examples and then we are done. Okay. So example 14 says find the power series representation for function using the integration. And from f of x, I didn't write this, but f of x is equal to ln of 5 minus x. So prime of x is, what's the derivative of ln of 5 minus x? Easy. It's 1 over 5 minus x times the derivative of the inner parentheses. So 0 to 5 is 0. The derivative of negative x is negative 1. So that is just negative 1 over 5 minus x. So what I would do next is make this 5 into a 1 by dividing everything by 5, right? It's going to be negative 1 over 5 over 5 divided by 5 is 1, or 5 over 5 minus x over 5. Excuse me. So that simplifies as negative 1/5 of 1 over 1 minus x over 5. And that gives you the summation of n equals 0 to infinity of negative 1/5 times x over 5 raised to the n. Okay, so now we have the summation of n equals 0 to infinity of negative 1 times x over 5, 1 plus n equals to negative 1 over 5 minus x. Now what we have to do is integrate. So go ahead and integrate both sides. And we get okay. Now let's start with the left side. This negative 1, let's make that easier. Let's make that into a positive 1 by factoring out that negative 1 dx. Now, how do you take the integral of 1 over 5 minus x? Simple. You use u substitution. So u is going to be 5 minus x. And then your du, the derivative of 5 is 1. I mean 0. The derivative of negative x is negative 1 dx. And you know what? I think we should have left that negative 1. Let's do that because that comes out nicely. Because you'll see that you get 1 over, and then you replace 5 minus x with u, and then you can replace negative 1 in dx with du. That's much better. And what is the integral of 1 over u? Exactly, ln of u. So our final answer will be ln of absolute value of u, which is 5 minus x. And then on the right, this would be the summation of n equals 0 to infinity of the integral of negative 1 times xn over 5 to the 1 plus n dx. Okay, so now we have ln of absolute value 5 minus x equals to the summation of n equals 0 to infinity of negative 1 times x to the n plus 1 over 5 to the 1 plus n of n plus 1 plus c. Now what you do is find c by letting x equal 0. So you get ln of 5 minus 0 equals the summation of 0 plus c. Okay, so your c is basically ln of 5, right? This is 0, and so you're left with c. So c equals ln of 5. So you could say ln of 5 minus x is equal to the summation of n equals 0 to infinity of -1 times x raised to the n plus 1 over 5 to the 1 plus n of n plus 1 plus ln of 5. Or you can also say ln 5 plus the summation of n equals 0 to infinity of -1 of n plus 1 over 5 plus n times n plus 1. Or you can also say ln of 5 minus the summation of n equals 0 to infinity of x to the n plus 1 over 5 of 1 plus n times n plus 1. Okay, let's do one last example and then that'll be it for this video. Okay, 15, example 15. Find the power series representation for the function using integration. We have f of x equals tan inverse of 2x. So first what I would do is take the derivative of f of x. So that would be f prime of x equals 2 over 1 plus 2x squared, right? The derivative tan inverse is that, and then that simplifies as 2 over 1 plus 4x squared. Then what I would do is somehow let's make this 2 into a 1. I would factor out that 2, so that would be 2 over 1 over 1 plus 4x squared. And then next I would make that positive into a negative. So that's going to be 2 over get the summation of n equals 0 to infinity 2 times -4x squared raised to the n, and then that gives you 2 times -1 times 4 times x squared raised to the n. and we get 2 to the negative 1 and 4n 1 get the n get 2 to the negative 1 raised to the n times 2 to the 2n times x to the 2n. And we get the summation of negative 1 raised to the n times 2 to the 2n plus 1 times x to the 2n. And we get f prime of x 2 over 1 plus 4x squared. That equals to the summation of n equals 0 to infinity of negative 1 and to the 2n plus 1 times x to the 2n. Then what you want to do is take the integration of both sides. So on the left, it would be the integral of 2 over 1 plus 4x squared dx equals to the integral of negative 1 raised to the n times 2 to the 2n plus 1 x to the 2n. Yeah. You get tan inverse 2x equals to the summation of n equals 0 to infinity, negative 1 to the n times 2 to the 2n plus 1 times x to the 2n plus 1 over 2n plus 1 plus c. Then what you want to do is solve for c by letting x equal 0, right? It would be tan inverse, and then 2 times 0 is 0 equals the summation. When you replace x with 0, everything else becomes 0, so it's just 0 plus c. So you get c equals 0. So you could say your final answer could be tan inverse 2x equals the summation of n equals 0 to infinity of negative 1 raised to the n times 2 to the 2n plus 1 times x to the 2n plus 1 all over 2n plus 1. And that's your final answer. Okay, so that wraps it up for power series.